very excited to be here and just share some technologies about Oracle and Web3 to all of you. And thanks for your time coming here, and also thanks for Square Dog for this opportunity that I can just meet so many builders and co-founders. So today my title is Build a Hybrid Smart Contract with ChainLink. So when I say the hybrid smart contract, which means that the smart contract can just handle the data on the blockchain and also handle the data from the Web2 world. So as an ecosystem, Web3 ecosystem keep growing, we want to move more and more business logic from the off-chain to on-chain smart contract. Maybe we want to build a Web3 version of the insurance. We want to build a Web3 version of the social-fi and social. And we definitely need some data from the Web2, right? So in order to just relay the data and the computing resources from the Web2, from the API, from the apps, from any Web2 tech giant to the smart contract, we need an infrastructure called Oracle to just help us to do that. And in today's session, we have give a very brief introduction about myself. My name is Frank, and I am a developer relation engineer in ChainLink Labs. So for those who have not heard about the ChainLink Labs, I just briefly introduced our service. And we are a Web3 company and provide a lot of the different Web3 services based on our Oracle network. We will talk about it later. And actually my duty is to reach as many builders as possible and help you to build your project. I can help you to solve your technical issue, and if you want to get more marketing resources, you want to get some incentives from the ChainLink ecosystem, you can reach me and I will see how I can help you. And in our session tonight, we have three topics. The first one, I will briefly introduce what is Oracle problem, why we need Oracle, and what is that. And after that, I will introduce some of the important Oracle services from ChainLink. And last, I will just give a very brief live coding here, and we will see if I have enough time because I only have a half hour today. So for the first one, the Oracle problem. So as we all know that there is the blockchain is actually a distributed or decentralized systems, and there is a lot of the different nodes running under the same network, and there is a very important thing to keep every different node under the network have the same data. So we have a process called a consensus, and based on the consensus algorithm, we need to make sure that every different node needs to execute the transaction and get the same result, and then we can just write this transaction into the block, and we can change the status of the blockchain. But if we want to get some data from the outside API, from the Web2 world, actually different node, if they want to get this kind of the data, they need to make something called indeterminate transaction. So think about it. In order to make sure that every different node under the blockchain network will have the same result by executing the same transaction, we need to make this transaction a deterministic one, so like a 1 plus 1. So there is a node to broadcast the result of the 1 plus 1 to all the other nodes under the network, and every node will execute 1 plus 1, and the result will always be 2. But if we want to get some data from the outside API, or if we want to get a random number on the blockchain, how we can do that? So if the node calculates a random number like 1, 2, 3, and they will post this transaction across the whole network, and a different node will execute this transaction, and definitely they will get different answers. That is called an indeterminate transaction, because that is a random number, so everyone will have the different result. And for the outside API, if I want to get what is the temperature of the Ho Chi Minh City tonight, the node 1 will get this get this data from the API, and the node 2 will get a data from another API. So they may get different answers, and if the answers are different, the data cannot go through the consensus, and this data cannot be written to the block. So that is called an Oracle problem. So the Oracle, actually, by its name, is here to solve this problem, to relay the data and the computing services from the Web2 world to the on-chain smart contract. So actually, the Oracle is not a quite new concept. From the very early stage of the Web3 industry, we have something called centralized oracles, and the architecture is pretty straightforward. We just run a server or a node off-chain, and we have some scripts running in this server, keep monitoring the status of the smart contract on the blockchain. If the status is changed or updated, this will be regarded as the request is sent. And if this request is detected by the off-chain server, the server will just get data from its own data sources and then write this data back to the smart contract. That is the Oracle. Pretty straightforward, right? But here is a problem called a single point failure. So think about it. The whole reason we want to build our application, we call it a decentralized application on the blockchain, we want to bear with a high transaction fee, is because we want our decentralized application is just secure, just transparent, and just fair. And if we just rely on outside data on a single node, if this node is compromised, or this node is just do something bad, the data, the security of the whole system will be compromised. And the answer or the solution for this question, for this problem, is called a decentralized Oracle network. By just setting a decentralized Oracle network, we kind of mimic the trust minimized feature in the blockchain, and we apply this feature in the data delivery layer, or we can call it the Oracle layer, and to use a decentralized network to just get data from the different data resources, and then we do a aggregation, and finally to submit this final report to the on-chain smart contract. So in the on-chain smart contract, it will verify the signatures from the different nodes to see if this is a valid request or if it is a valid response. And by doing this, if any node under this network is compromised, or if some nodes in this network is just down, the service will not be suspended and the whole security will not be compromised. So that is called a decentralized Oracle network. That is also the infrastructure of the ChainLink. So based on the decentralized Oracle network, we have three different types of services: a data service, and a computing service, and a cross-chain service. And in today's workshop, I'm going to introduce the data feeds in the data service and the CCIP in the cross-chain service. Because for the ChainLink, we are a very, very big developer platform. And based on this developer platform, you can build a DeFi, you can build the GameFi, you can build nearly everything if you want to bridge the data from the Web 2 to the Web 3, or if you want to bridge the data from the chain A, from the source chain, to the chain B, to the destination chain. And if you want to do anything like that, you need the service from the Oracle. So let's first to talk about data feed. That is actually the most famous service provided by ChainLink. We actually start to provide this service in I think in the 2020 or 2019, just before the DeFi summer. So if you are going to build something like a DeFi or some applications related to the finance, there is a very, very decent chance that you need to use the data feed to get the price data of the asset for your smart contract. So for the data feed, the whole workflow is like this. So as we talked before, we have this one, the DON, the decentralized Oracle network. And this decentralized Oracle network will just keep updating the price data on the blockchain. And after we have the two conditions to see if one of these conditions is met, there will be a new trigger for the data price update. So for the decentralized Oracle network, the node will get the data from its own data sources, and after every different node under this network get the data, they will just talk to each other and aggregate this data together and generate a report with their signatures and submit this report to an on-chain smart contract deployed by the ChainLink Labs. This smart contract will check the signatures in this report to see if this report, if this data is valid. And if everything is fine, the data will be written into the smart contract and it can be used by the developer, by the user smart contract, or we can call it a consumer smart contract. Okay, so here is our app for the data feed. As you can see here, we have a different node running for the different asset pair. For the ETH/USD, we have like a 32 Oracle node running as this network, and to get the data from its own data source, and to just check the price of the Ethereum, and to aggregate the price of the Ethereum and generate the report, like I said before, and submit this report on chain. And so what are the use cases? So mostly like DeFi. So if you want to build a lending and a borrowing protocol, you actually want to know the value or the price of the asset user collateralized on your platform, on your protocol. And if the price is actually compromised, if the data is compromised, or if the data is wrong, there's going to be a very bad result. Maybe the user can collateralize something worth of the $100 and the Oracle price is attacked, or something is changed, the price will just increase from the 100 to the 1,000, and the user can just lend a lot of the liquidity from your pool. So other stakers in your protocol will lose their money, right? And except for the lending and borrowing protocol, you can also use a data feed in the synthetic asset. So the original idea of the synthetic asset is to allow the traders on the blockchain not only trade the blockchain native asset, but also trade the stock market, like a fiat, and like a commodity. So in the data feed, we not only provide the price of the token, but also provide the price of the asset from a lot of different assets. And for the stablecoin, you can know that the value of the collateralized data to decide how many stablecoins, how much money they can print on chain, right? And also for the asset management and option and future, you all know that it is very important for this protocol to make sure the price of the asset in this protocol are correct. Okay, so here is the second one. It's called ChainLink functions. So for the first service in the data part, we provide the standard data of the asset, of the token, of the stock market. But if we want to get some data, like if the flight is delayed or not, if we want to get a data like a temperature, if we want to get a data like if today is sunny or rainy, well, data feed cannot provide this customized or non-normalized data. So if we want to build a Web3 version of the different business logic, we need to know how to get the customer data, how to get unnormalized data. So for example, like we want to build a Web3 version of the insurance to just for the flight delay. So if the flight is delayed, we will offer a payout to the client. But we need to know if the flight is delayed or not. How we can know that? We need to check the API from the flight company. We need to know the weather data from some API. And we also want to get this data in a very decentralized manner. We want to have a network. We want to have a decentralized network to help us to get the data from the off-chain, from the Web2 world. So let's see how we can do this. So as similar like the data feeds, the ChainLink functions also use the DON, the decentralized Oracle network, and different from the data feed, in the ChainLink functions, user can write their own request, their own customized request in the JavaScript or some other programming language, and make it a request and wrap with the ChainLink functions. And ChainLink functions will send this request to the off-chain Oracle network. Actually, we just image this event, and if this data is emitted in an event, the off-chain Oracle network will detect there is a request and fetch everything in this event, including a request in the JavaScript, maybe. And in the decentralized Oracle network, every node will execute this request in its own environment and get the data or do a computation. And after everything is done, they will, like before, talk to each other and aggregate the data and just feed this back to the on-chain smart contract. So that is for the ChainLink functions. And we actually have a website called usechainkfunctions.com. We write some use cases in this website, like how to get the data from the AI service, how to get the data from the stock market, how to get actually, this gives you the flexibility that you can build anything that is existing in the Web2 world. In the Web2 world, we have a social, we have a trading, we have any apps, and we can use the chain functions to get nearly every data from the Web2 world. And for example, like AWS, we have a data exchange that is, as far as I know, is the largest data exchange in the world. And any data you can get from the data exchange, you can bridge this data to the on-chain smart contract with the ChainLink functions. And also with the Twilio, you can use this Twilio API to just send the request to the users based on its on-chain behavior if they bind the identity of the Web2 and the Web3 together. Okay, cool. So the last one I want to mention is CCIP. That is the latest ChainLink service published this year. And CCIP, the full name of the CCIP is ChainLink Cross-Chain Interoperability Protocol. And for the ChainLink Cross-Chain service, actually it's kind of more complicated than the last two services, because in the ChainLink Cross-Chain Interoperability Protocol, we actually have 3 decentralized Oracle network to bridge the data from the chain A to chain B, from the source chain to the destination chain. So first, let me make it clear. So when I talk about a cross-chain, I know most of people may think about we need to move the token, we need to transfer the token from the source chain to the destination chain. I have a Ethereum on the Polygon, and I want this Ethereum to be on Base. How can I do that? I need to transfer my token from the one chain to another chain. Actually, that is a level 1 of the cross chain. But if you abstract it, if we can just send any arbitrary data from the source chain to the destination chain, we can nearly achieve anything. So, like transfer the token from the chain A to chain B, what we actually do is to tell the blockchain B that we have already locked or burn a token on the blockchain A, and then please just release or mint the same amount of the token on the blockchain B to the same address. We just need to tell or need to sync up this message from the chain A to chain B. We can achieve the token transfer. So the ChainLink CCIP is actually a protocol for the arbitrary data transfer from the chain A to chain B. So to transfer a arbitrary data or a message from the chain A to chain B, we have 3 steps. So the first one, we have the decentralized Oracle network, the DON number 1, to just relay this data, to get the data from the source chain and write it to the blockchain B, to the destination chain. And the second step, the step number 2, we have the second Oracle network to just keep monitoring if something bad happened in the step number 1. So if the first DON just transfers the wrong data, release the wrong data, the second one will just keep monitoring that to see if there is something bad happen. And if everything is fine, the second Oracle network will bless or certify this transaction is valid. That is a valid transaction. And after this transaction is marked as valid, the third one will come to play and to say like, hey, I need to execute this transaction on the destination chain. And the whole process is like this. And by doing this, we can nearly send any cross-chain transactions from the blockchain A to use the blockchain B, and we can we can do something like I want to mint a NFT of a smart contract that is deployed on another blockchain where that I do not have any fund, and I can send a cross-chain transaction from the chain A to chain B to mint a NFT which is deployed in another blockchain. So that is the CCIP. So with the CCIP, you can send a cross-chain transaction to achieve anything you want to do. And as a developer, as a builder, you can provide something like an interface of your application to the different blockchain, because the users today reside on the different blockchains. The liquidity is fragmented. You cannot only build your app on the single chain because you want to get as more developers or more users as possible to use your app. So you need to provide interface to them. Okay, cool. So with CCIP, I know the true innovations is always from the community. So I'm also very excited to see you can build something with CCIP. But for now, we see some possible use cases with CCIP. So first one is cross-chain collateralization. So maybe some users with a lot of the asset want to keep their asset in the high secure blockchain like Ethereum mainnet. And they can collateralize their fund on the mainnet and get some liquidity on the Polygon, on the base, and to use this liquidity to do some interactions with the different apps. And we can also do the cross-chain governance, like some big project. And the big project will be deployed on the multiple blockchains. And as a token holder, or in the different blockchains. So if one token holder make a proposal and other token holders want to vote this proposal to be passed or not, how we can do that? Because the users are in the different blockchains. So we can use a cross-chain governance to help the project governance to make the vote and the proposal easier than before. And we can also use the CCIP to do the cross-chain trading. We can just connect the different DeFi project as Legos together, even if this application or deployed in the different blockchains. And also for the enterprise workflow, like RWA, the financial institutions like banks and some other companies which hold a lot of the assets. They want to build their own bank chain or app chain, and they will on-chain their asset, but they need to connect their bank chain or app chains with the mainnet with different blockchains, and we can use the CCIP to connect them together to increase the liquidity of the asset they want to be traded. Okay, actually I have 10 minutes of the live coding with the CCIP, but I don't think I have enough time. Okay, only 5? Let me just introduce what I'm going to do, and without really doing that, you can follow the documentation of the ChainLink to achieve it in very easy. So in the demo, what we want to do is that I just transfer a arbitrary message from the chain A to chain B. So I can just use a consumer or build my consumer smart contract, the user smart contract, and add a function as a send CCIP message in my smart contract and inherit from the CCIP smart contract to write something into this transaction and click the button, maybe in the remix, or if you use a hard hat or foundry, you just create a script to trigger this function. And this data will be detected by the DON we said before. And after the 3 steps, like commit, blast, and execute, your data will be written into another blockchain, which is going to be a base or something else. So by doing this, you can just cross-chain the messages among the different blockchains. It's Avalanche, Base, Polygon, Chalo, and Ethereum, and any public, mainstream public blockchains, or we support any. I think for the EVM, we nearly support any popular blockchains, and you can see the list in the document. Because I do not have enough time to do the demo, but I can show the demo here. So the demo, we have a documentation called docs.chain.link. Everything I taught today will be here, and you can find everything here. And we have 6, actually 7, but we have 6 services here in the documentation. And if you click the CCIP, you will see that here are the sample code, and we have a supported network. And let me check the mainnet. See, we have support a lot of the different EVM blockchains like Ethereum, This is the optimism and Arbitrum, Polygon, Avalanche. And if you have your application deployed in any of these blockchains, you can use the CCAP to provide an interface to the users who are residing in the other blockchains to extend your app from the single chain to the multi-chain. Okay, I think the technical stuff is